in this problem, we need to identify which of the following matrices are rotation matrices. We have 5 square matrices here. And to do that, let's review how can we tell if square matrix is rotation matrix or no. So basically there is a rule that a square matrix A is a rotation matrix if a transpose of matrix A is equal to the inverse of matrix A, and determinant of A is equal to 1. So what we need to do here, we need to analyze each of our matrices and see if they satisfy these two identities. So let's start with matrix A. First, matrix A, we will copy paste it. So the first thing which we need to do, we need to find the determinant of matrix A. The determinant of A. And it would be equal to 1 minus 0, which is 1. So this part is satisfied. Next thing is that we need to look at the transpose of matrix A. So let's find the transpose of matrix A. It would be equal to 1, 0, 0, 1. So basically the transpose of matrix A is equal to matrix A. Now let's find the inverse matrix. So this would be equal to 1 over determinant of A multiplied by negative by 1. Here we have negative 0, and 1. So basically this is equal to 1 over 1 multiplied by the matrix 1, 0, 0, 1, which is equal to this matrix. As we see, the inverse of matrix A is equal to matrix A, and it's also equal to the transpose of matrix A. So we come to the conclusion that the transpose of matrix A is equal to the inverse of matrix A, which means that matrix A is a rotation matrix. Rotation matrix. Now we will follow the same steps to analyze matrix B. So we will copy paste it. Matrix B. So the determinant of matrix B is equal to 0 minus 0, which is equal to 0. That means that determinant of matrix B is not equal to 1. So matrix B cannot be a rotation matrix. We don't even need to look at the transpose of matrix B, at the inverse of matrix B, because we see that determinant of matrix B doesn't meet the requirement. So matrix B is definitely not a rotation matrix. Well, now we will do the same thing with matrix C. So the determinant of matrix C. The determinant of matrix C is equal to 1 minus 0, which is 1. So this requirement is met. And now we will look at the transpose of matrix C. So the transpose of matrix C is equal to 1, 1, 0, 1. And now we will find the inverse of matrix C. This is equal to 1 over 1 times 1. Here we will have minus 1. Here we will have 0 and 1. So our result is 1, negative 1, 0, 1. As we see, the transpose of matrix C is not equal to the inverse of matrix C. So we can write it down. The transpose matrix C is not equal to the inverse of matrix C, which means that matrix C is not a rotation matrix. Not a rotation matrix. Okay, let's move on to the matrix D. Again, we will duplicate it. So let's start with the determinant of matrix D. It would be equal to 0 minus 1, which is negative 1. Again, we see that the determinant of matrix D is not equal to 1, which means the matrix D cannot be a rotation matrix. So D is not a rotation matrix. And our last matrix, matrix E. Matrix E. So again, let's find the determinant of matrix E. It's equal to 1 minus 0, which is 1. Okay, this requirement is met. Now we will look at the transpose of matrix E. So the transpose of matrix E is equal to negative 1. Here we have 0. Here we have 0 and negative 1. Well, now let's find the inverse matrix. So it's 1 over determinant of matrix E times negative 1, negative 0, negative 0, negative 1, which is equal to 1 over 1 times negative 1, 0, 0, negative 1, and we get negative 1, 0, 0, negative 1. As we see, the transpose of matrix E is equal to the inverse of matrix E. So let's write it down. E transpose is equal to E inversed. And that means that both requirements are met. So matrix E is a rotation matrix. Rotation matrix. So now we come to the conclusion that the only rotation matrices here are matrices A and E. So A and E.